SIMATIC Energy Suite is a software solution offered by Siemens for energy management in industrial and commercial facilities. It provides real-time monitoring and analysis of energy consumption, allowing facility managers to identify inefficiencies, optimize energy use, and reduce energy costs. Automation can be used at different levels in an industrial commercial setting. Automation at the management level is focused on providing high-level insights and analysis to help decision makers make informed decisions. Automation at a production level focuses on improving efficiency and productivity in the manufacturing process. Automation at a field level is focused on monitoring and controlling the operations of the field equipment such as pumps, valves, and motors. Each level of automation has its own benefits and can contribute to improved efficiency, increased productivity, and reduced cost. Incorporating metering into an energy management system provides facility managers with a comprehensive view of energy consumption and usage patterns. Since energy metering plays such a critical role in energy management, it's really nice to be able to have a comfortable integration of energy data with SIMATIC Energy Suite. Through the use of the meters as you can see above, such as the multi-case circuit breaker 3VA, metering can be incorporated into the device. Once the data is collected, processing and monitoring can begin. Processing and monitoring of energy management data can be complex. However, with the right energy management software and tools, processing and monitoring energy management data can be made easier. These tools can automate the data collection process, provide real-time insights, and offer intuitive dashboards and visualizations that make data analysis and decision-making easier. Energy meter placement is a critical aspect of power metering and is determined by the specific use case and requirements of the facility. Factors such as the type and size of the facility, the number of energy consumers, and the desired level of granularity in the energy consumption data will all impact energy meter placement. In the example here, one could see that the ET200SP energy meter could easily be used in either energy distribution or production machine environments. By aggregating energy data at a controller level, facilities can gain a more comprehensive view of energy consumption and identify areas for improvement. Energy data aggregation at the controller level of automation refers to the process of collecting, consolidating, and analyzing energy data from multiple sources within the facility. In the diagram, energy data is aggregated back to the S7-1512SP using Energy Suite. This PLC buffers data and works in conjunction with the SCADA. SIMATIC Energy Suite provides innovations in efficiency through use of easy integration of the measuring devices. Auto-generation of the code also helps with consistent information and data buffering at the PLC. Energy Suite also extends auto-generation into the visualization and archiving areas. From there, the data is ready for KPI calculations or even analysis and other tools. Today's demonstration will use many of the parts that you see here in front of you, including the SIMATIC S7-1500 PLC, a COM800 breaker data server, switched Ethernet Profinet expansion module, COM60 communication module, as well as a 3VA molded case circuit breaker, along with a few T connectors to connect the energy components. Let's go ahead and look at the installation process for a Profinet expansion module. In this example, a COM800 in system connected to a 3VA6 is already established and put in place. The expansion module can be screwed into place, and a network connection supplied between the expansion module and the PLC. Right now, we'll treat the device that we just installed the expansion port on as if it were new and unprogrammed. Here you can see through the accessible devices in the online and diagnostics that we can come to the functions and assign things like IP address and Profinet device name for the very first time. Once the parameters are configured, just hit Assign IP. Next, moving to the Profinet device name. here with a meaningful name if we can. And then you can see correctly displayed here by name and IP address. So what's next is that we can use Profinet to our advantage and discover the device and upload it as a new station. This allows us to bypass having to build it piece by piece. We'll go ahead and select the ENO3VA6, the switched Ethernet expansion module, and hit upload. So now with the module in place, it's visible within the network view, but also the project tree. Double-clicking or using the tab device view brings us into the device viewer. This is where bulk of the programming and configuration of the device is determined. As I just mentioned, within the device view, it's pretty easy to adjust the parameters within the properties area of the device, as well as seeing things like the firmware of the relevant pieces underneath the device overview. Next, it's time to assign the I/O device and create energy data. Checking the I/O device box and then selecting PLC 1511C allows us to assign the I/O device to the I/O controller. Notice the insertion of the control bytes, as well as if we insert measurement data, you will find the data there also. Under the Energy Objects folder, you'll see the ability to add a new acquisition object table. Minimally, we need to provide a name and provide the energy data source that we previously configured. Last but not least, the archiving period here we've set for 1 minute to make it really quick for our reading. But if you want to create your own archiving, this is done under the Energy Program settings. And here you can see I've selected this one as the default. Archiving and buffering, it can be solved by 2 different methods, up to and including advanced communication settings between the PLC and WinCC for archiving. Again, with the connection settings, I'm going to speed things up a bit for our demonstration. Obviously, these settings should be applied according to your specifications. The Energy Suite license count can also be viewed here. Now it's time to go into the properties area of the configured energy object. A few things that we'll adjust are the advanced data, and we'll also try to acquire the min and maximum values of the advanced energy data. Here with the energy counter value, we can provide different units as well as the flow of energy type. And then for processing, again, we're just going to speed things up a little bit. That way we can see some values jumping around for our demonstration. Once we're ready to generate the energy program, the first thing I'm going to select is the customized program generation because we're only going to use the energy acquisition portion. We have not configured a peak load management section at all. Load management is outside the scope of this demonstration. Here you can see that the compilation gives us a generated error. Clicking on the green Go To button will provide us a jump to the actual error where we should look for any of the red indications highlighted. Using the purchased runtime license, you can apply it in this area. So now it's time to regenerate the energy program, and it's finally completed without errors. This time I selected the complete energy program so we could demonstrate the warnings that could pop up if you don't configure a load management. Now that we've generated the programming, let's go investigate to see what's there. Under the acquisition objects, we'll find the advanced data block. Within this structure, you'll find the most detailed tags. I'll go ahead and speed things up with the load preview here, or we'll just download to the PLC. We added hardware, so the PLC does go to stop, and we'll start the module. Once we load, we go online. Quickly, you can see the Profinet expansion module went green. And here's some of our data. You can see there are totalized values down at the bottom. Next, it's time to work with SIMATIC, which is our way of automating the HMI visualization. Those screen rules are placed inside of the appropriate folder down at the bottom of the project tree. Screen rules help us define rule triggers that are based on function blocks, which also help us to guide objects from the library to be placed into specified screen windows inside of our runtime. So let's go ahead and generate our HMI. For this, we're going to use Unified PC Runtime, placed inside of a PC station. The hardware catalog provides us with communication modules, such as the IE General in this case, and also the SIMATIC HMI application that we're going to use, WinCC Unified PC. Now it's time to configure the IPC or PC General itself. First, we need to know the IP address. Here, the outbound IP address is .191 in my case. And then for the computer name, which really helps resolve better since we are using web-based HMI here. Here you can see it's called Field PG1. So from there, it's time to attach the module. We'll apply a connection here. It's got to be networked. And in case this ever happens to you, it's good to note you must be offline of the PLC in order to modify a hardware connection. Clicking the Connections option and ensuring you have the HMI connection enabled, drag and drop from the runtime to the PLC. The HMI connection can be found also in the Connections area, where you can investigate things like the properties, the exact same parameters and configurations can be adjusted in a similar way in this area. So going to the HMI and going to the runtime connections, it's really important to note the different options that we do have. The drop-down menu shows you the different communication drivers that are available for Unified PC Runtime. The last thing to do is to place the HMI Connection Password inside this field here. So there are two errors that resolve here. One is the effect of an encrypted transfer password configuration. Here you'll see me deactivate it for the demonstration here. And then also that we don't have a declared start screen. That's okay, we're going to fix that now because we'll use SIMATIC to auto-generate the HMI. What we got to do is select the PLC that we want to connect to with SIMATIC, and that will link us with the HMI. Processed with no errors. And now we can go ahead and link the start screen. Alright, once we've selected WinCC Unified Screen of Choice, we can now talk about how we log data using the tool. Hit the refresh button to make sure everything's up to date. And if we had any actors, they would show up in this field, but we don't. We're going to hit Create Data Log, and then it will auto-generate the data log for us as well. Notice it opened and expanded some HMI tags. But if we check the log setting, which we'll do in a second, first we'll check the HMI tags. With the Logging Tags tab open, you'll see the generated tags and logs. In the Data Logs tab, you can find the same values there too. With the extended download possible, we'll go ahead and download to the HMI. And under the prompt, really the important takeaway is to see the runtime values. Here we'll want to change the runtime values because we want to overwrite the user administration. We'll start out by doing a full download, and then we'll start the runtime upon launch. Last but not least, on the first download, the suggestion is to make sure that we uncheck Keep Current User Administration Data in Runtime. That way we can download the new user administration. Last but not least, we'll just go ahead and load. Now for our WinCC Unified PC Runtime, we can visit this using Chrome, for example. And I'll launch the runtime. Here we can see the icon and then the pop-up. The pop-up launches, and then we can also see that we're already aggregating data and populating it here in this graph. Pretty quick, right? So all this is cool while you're commissioning, but why choose TIA Portal? TIA Portal is really useful for after the fact. TIA Portal as a tool provides things like diagnostics with this built-in alarm display. We can investigate each PLC or each part. But for example, here with the PLC is saying that our archiving error connection HMI data log interrupted. This error is an artifact of the fact that I'm running a trial on my runtime licensing and is not typical. Here's one that I generated myself by placing the PLC in stop. A unique feature of the Profinet along with the S7-1500 PLC is that despite the PLC being in stop mode, we can still scan the network and the components to determine their diagnostics. So for example, even though the PLC is in stop, the COM800 module here is still reporting its statuses and being reported. Removing any of the cabling all the way down to the breaker also produces similar errors. So if I unplug the Profinet cable from the COM800, pretty quickly you'll see it'll generate an alarm indicating that the component was removed or missing. Now what's nice about this work area is I can acknowledge alarms as well as keep an alarm archive. Placing the Profinet cable back in should remedy the situation, and then you'll see that the alarm is now outgoing and goes away. Pretty great tool. Now let's see what the HMI has in store. For WinCC, we have a diagnostics overview. This overview can be applied from the toolbox. And under the control setting, look for the System Diagnostics overview. This is a drag-in tool. Once you drag it in, it's actually complete. There's nothing extra to program here. This overview taps into the central alarm management that comes directly from the PLC. This is also the central alarm management that we just saw in the diagnostics area of the PLC alarm display. Once we get it situated, we'll compile. And then go ahead and load to the field PG. Get the runtime running with the new changes. Here's the updated changes. What you can see here in the diagnostics overview is a simplified block format of our devices. So for example, if we expand the Profinet I/O system, You can see the 3VA6 COM800 along with the breaker one. Another advantage here is that you can see the PLC's diagnostics buffer, along with seeing details about each diagnostics entry. So why not? Let's go ahead and generate the same alarm again. I'm going to pull the cabling out of the station here. I pretty quickly found that breaker 1 was an error. And again, we have a hardware component that's been removed or missing. Plugging the cable back in remedies the error. The remainder of this demo are extended topics that are outside the scope of Energy Suite. I also feel like I wouldn't be demonstrating much if we didn't talk a little bit about the control bytes that are available from the device, being that it's an I/O device. We can pull in the I and Q addressing that you see here. Using the default tag table, we'll go ahead and declare some control and status words for the 3VA6 breaker. These tags could be used throughout programming situationally. For example, in the HMI, these tags could be used to provide feedback about the breaker visually. I've made some PLC data types ahead of time that help us to decode the meaning of the bits within these words. In order to apply the status words, we need to align them with the bytes. In order to align it with the addressing for the 3VA6 on the COM800, notice the I and Q addressing up at the top there for the device view. These need to match the addressing in the tag table, for example. The Q address 126 for the control, and the I address 124 for the status. We'll go ahead and download this to the PLC. Notice the compilation and then the loading. Finally, we can finish and start the module. And then we'll start by going online with the PLC. And we'll go online to see that. And then we actually have data within the status control word. The last thing that we need to do is implement a function call for decoding the 3VA6 status that we just read in. And then finally, I'm going to drop in a global data block, which contains the landing spot for our decoded values. It's these decoded values that become useful in the HMI. So highlighting the global controls and dragging the status and control words to the in-out section of my block, along with aligning the status and control words from my tag table, allows the function call to operate without errors. Finally, one last download to the PLC. And everything's green in terms of status on the project tree. Finally, we can finish working with the HMI. Here I've prepped a group called breaker. The grouping actually contains lines and some stacked images under our resource list. This resource list can be dynamized via a tag. Finally, we get the HMI quick compilation. And I'll bring this diagnostics overview up above the line. Notice that we have an error, and just to demonstrate how we could also use the go-to option in order to find errors in the HMI, we need to align this tag here for the state value of the breaker. This tag is located under the program blocks. And call within the main back on our FCD code block. From there, the global controls tag can be found in the global's data block. Remember, this is under the OB structure, and then if we expand global controls, we'll find the individual structures for each one of those tags. We'll select the status, and then look for the state value, and click the green check mark. Finally, we'll expand and look at the actual resource list itself that we're indexing through, which ends up being pictures that allow us to dynamize them by a number. We'll do an additional download to the HMI. And this time I simply just need to load the runtime and tell the runtime to start upon completion. Now it's time to visit the HMI to see the diagnostic status available. Here you can see me open, close, and trip the breaker. That wasn't too bad, was it? We also have the web server available for diagnostics within the PLC. The web server diagnostics is highly regarded, and I actually use it quite a bit. One of my favorite spots to show is this diagnostics runtime information area. Here you can see things like communication load and cycle time. I really like this live graph. Another interesting place that we can visit is that we can have user-defined HMIs. And here with the WinCC unified view of things, I can actually have a very small HMI inside the PLC. So for this demonstration, I have a filling station. Notice I can hit start. Yep, so moving back to the web server, it's really nice to also show that the same module information is available, like I've already previously demonstrated in a few other areas. Here you can see I've generated the exact same error for us to see inside the web server, where I've unplugged the Profinet cabling to the COM800, losing status with breaker 1. Last but not least, the PLC diagnostics right off the front panel of the PLC itself. I'll just locate the Profinet IO system here, and then again you can see the ENO3VA6 error, which also tells me that the IO device is not found. That sure is a lot of diagnostics out of the HMI, the PLC, and also the engineering software itself. So after all this, we've demonstrated that processing and monitoring of energy management data isn't hard after all. And I really wouldn't be going full circle if we didn't make our way all the way up into Energy Manager. SIMATIC Energy Manager Pro provides additional functions for comprehensive ISO-compliant energy management. The software supports the user with extensive reporting for recording and visualizing performance indicators and consumption data, and with tools for calculating performance indicators for more complex situations. Energy Manager Pro also permits batch-related or material-related consumption analysis and forecast of energy consumption. Various automation-level systems can be integrated via numerous interfaces. If you like, you can take it for a test drive yourself here with the demo server. By signing up, you're given access with a username and password where you can log in. What's nice about this demo is they have a few different lines running geographically, but just remember that SIMATIC Energy Suite provides energy transparency in production. This is the option inside TIA Portal. You can achieve a company-wide energy management with SIMATIC Energy Manager. SIMATIC Energy Manager is the energy management system for industry, certified in accordance with ISO 50001.